Today we will study about estimation of parameter. Now in statistics or statistical inference, it is mainly concerned with making inferences regarding the unknown aspects of the distribution of a population which is based on samples taken from it. The unknown aspects may be of the form maybe the form of a distribution or the values of the parameters or both involved. Now, it is true that a complete enumeration of the population will bring out all the unknown aspects completely, but this involves wastage of much time and energy, and in the case of infinite population, this is not possible. So, this is why we think of using samples to make inferences regarding the distribution. So, there are some methods that are developed to measure the validity of the inferences in terms of probability, and they are broadly classified into estimation of parameters and testing of hypothesis. Okay, so that is statistical inference is broadly classified into two. One is the estimation of parameter and testing of hypothesis. Now in this chapter we will be dealing with the first part, that is the estimation of parameter. So again, estimation of parameter estimation deals with the methods of determining values or numbers of the unknown parameters, as well as with the determination of the intervals in which this unknown parameters are in, with a specified probability based on samples taken from the population. Now regarding testing, I won't be talking much about that because you'll be studying that in your next class. Now estimation itself, you have two kinds of estimation, that is point and interval estimation. So for the time being we will study about the point estimation. Any statistic, or what is a statistic? It is a function of the sample values, is suggested as an estimate of an unknown parameter, is called a point estimate of that parameter. Consider, for example, a normal population with unknown mean. If we suggest the mean of a random sample taken from the population is an estimate, it is a point estimate of the mean. The sample standard deviation is a point estimate of the standard deviation of the population. Okay, in general, if fx theta is the PDF of a population where theta is a parameter, any statistic t suggested as estimate of theta is called a point estimate of theta. Evidently, a point estimate is a random variable. Now, we can have a number of point estimates for a known parameter, as any statistic may be suggested as a point estimate. If the population is normal, we may suggest we may suggest the mean, median and mode, standard deviation, third moment, or any other function of the sample value as the population mean. The same case is with the population variance. So it is natural to ask the question like, which is the best estimate? So the answer depends on our ideas about the desirable properties of a good estimate, and according to R.A. Fisher, the most important desirable property of a good estimate is unbiasedness, consistency, efficiency and sufficiency. So if it satisfies, if a particular estimate satisfy all these four properties of a good estimate, then we will say that that particular estimate is a good estimate. Okay, so let's have a look at the first property, that is unbiasedness. Now let T be a statistic suggested as an estimate of the parameter theta. Then T is said to be an unbiased estimate of theta if this is satisfied, that is expectation of that T will be equal to the parameter theta. An estimator is said to be unbiased if its expected value, that is, this is the expected value, is identical with the population parameter, okay, which is being estimated. That is, consider the possible samples of specified size n that may be taken from a population. Corresponding to each sample you will have a t. By saying that t is an unbiased estimate of theta, we mean that the arithmetic mean, so each sample have a value of t, so you imagine the arithmetic mean of t, or the mean of t, the possible value of t is the value of what? The parameter theta. That is, what is the parameter theta? It is something associated with your population. So that is all about unbiasedness, the first property, and we will have some results and problems regarding unbiasedness in the next part. Thank you.